All right. So we're going to do a lesson, and this one is going to have really two things on it. Um, Derivative of an inverse. And this one is new. Okay, so just know that this one is a new thing that you have not um, been exposed to yet. Um, so so I just need to kind of make sure that you understand that we haven't covered this one yet. Um, so it's the kind of thing. Well, this is a new topic, right? Sorry. And and what we have on this is the following. Okay, so this is a new topic, never been seen before by you. Used to be on the AP exam, maybe uh, maybe on the multiple choice, usually at the end of the multiple choice. I don't know if it'll be on the free response. It showed up one time in the past 20 years on the free response question. I hate to not go over it with you just because what if it's there? I don't think it'll be there, but it's hard to predict this year. So, first of all, let me just write down the formula and then we'll talk about what inverses are and everything. So, that's the inverse notation. If you're doing the derivative of an inverse, it's equal to 1 over the derivative of the function evaluated at the inverse. Now, I know that is a lot of notation, but that's something you're going to want to write down. Um, Now, there's some pretty typical things that happen with this. One of the things that happens is you normally get a table with it. I think I assigned two problems on Delta Math, and one will show up and it'll be functions, and the other one that'll show up will have a table on it. I hope you do one of each because having practice at that would be good in case it does show up on the exam. But one of the things that you really need to hone in on is inverses switch the x and y values. Meaning, if f has a point a comma b, then the inverse has a point b comma a. So the x and the y values switch. Really important thing. So let's say I give you a problem, and I'll just do an example, and I think that'll be the best. And go back and review the example if you need to. Um, but let me just go through this example. So the example would be, um, let's say f of x is equal to 3, sorry, whoops, rewrite that, 2x cubed plus 5x plus 2. They give you f of 1 is equal to 9, and g is the inverse of f. And the question is, what is the value of g prime of 9? So that's the question. What's the value of g prime of 9? Now, so here's the whole problem. Now you know that g is an inverse. So if we go back to our thing, just know that g being an inverse, g is actually equal to the inverse of f. So really important thing. So let's go back to the formula that I wrote out right at the beginning, and let's talk about what that looks like then, because that means g prime of x is equal to 1 over f prime of g of x. Really important piece, right? So if you go back to what I wrote out originally, right up there, you can see that if g is really the inverse of f, then all I did is I put g in for that inverse notation. So now what do we do with this? So here's what we do. We kind of go, okay, we're asked to find g prime of 9, which means we have 1 over f prime of g of 9. Oops, let me write that better. So at this point, we really need to know, what is g of 9? Well, let's look at the other information we have. The other piece of information that we have on this is the fact that f of 1 is equal to 9. So f of 1 is equal to 9. Well, if f of 1 is equal to 9, then from this, because the x-coordinates switch, then g of 9 would have to equal 1. That's a really important piece because that's what we're going to insert into that function. Now, we also need f prime of x. Well, f prime of x in this problem is really pretty easy. It's a pretty easy polynomial to take the derivative of. You get 6x squared plus 5, and then the 2 goes away because you differentiate 2, you get 0. So let's combine this information that we needed and what we're supposed to find. If you think about what we have now, is we're looking at, okay, g prime of 9 must be 1 over f prime of 1. So that is 1 over 6 times 1 squared plus 5, or 1 over 11. So hopefully that makes some sense to you. Go back and look at that again. You know, when you're doing the assignment, go back and look at that. I'll try to post these notes up there, but go back and take a look at that. So the other piece that we're doing today to kind of round out this week, there won't be any more new topics after today, but to round out this week, we're going to look at implicit differentiation. And we've done this topic before, so this is not new to you guys. So let's just say let's say I have an equation. Let me pull something up here. Let's say I was going to do, and I'll just do an example because after all this, doing the examples, that we've done this problem, this work before, so we should know how to do implicit differentiation, or at least you should recognize it after I do a problem. And then, so you might have this, and it might say find dy over dx. So if we're going to find dy over dx, remember that this is the same thing really as y prime, right? So find y prime. So if we think about differentiating this, if I go through and differentiate this, I would have negative 2y times y prime. Now look back at the original. There's a multiplication in there. You have to use the product rule. So we have minus 1 times y minus x times y prime. So that's the product rule. Minus 2 equals 0. So all we've done is we've differentiated this thing. Now we end up having to just take this and solve for y prime. So negative 2y prime minus x y prime has to equal 2 plus y. If I move the negative 1y and the 2 over to the other side. If I factor out a y prime, negative 2y minus x is equal to 2 plus y. And then finally, if I divide by negative 2y minus x, there's my derivative. And from there, I can do a lot of different things. It might be the kind of thing that it says, find the derivative at a certain point for x and y, and you just plug in x and y. You certainly could write the equation of a tangent line off of this. But that's how you do implicit differentiation. That kind of rounds out what we're doing for this week, and hopefully it makes sense to you, and that's it. So we'll talk to you later. Thanks.